Everyone. Uh, in the first and second video that present for you, I don't know if I made myself clear, explain about the transmission line structure, the way that it's modulated. So in this video, which I don't know if I gonna make a part of this series, I just wanna make myself clear on the way that the transmission line is modulated, which is pretty simple. Let's dive into, and I'm gonna try my best now. Uh, as you know now, is our transmission line is a inductor in series with a resistive element. And right now, I already wanted to start modulating this piece of the structure with you, and you're gonna see that is easy. So let's see. A current which across inductor has a voltage drop, the same for the resistor, and we know this from our electronics or any class of electronics or electrical engineer. You're gonna see your teacher doing these basics. So we have VR, which is a voltage drop. We have VL here, IL, IR, and you already know that VL is equal to the value of L, the inductor, times the derivative of the rate of change, which is the derivative of VL IL with respective to time, and this is the rate of change of the current across in the inductor. And this is even more easy, is the Ohm's law, which is V is equal R times I, times I. And if we sum these terms, we're going to obtain this first section of the structure. See? Easy. And the other part of the structure was a capacitor in parallel with a resistive element represented the conductance, and You also know how a voltage drop given by given by a current crossing it is for a capacitor. C times the rate of change of the potential on the capacitor with respect to time is the way that the capacitor charge in the start. The conductance G is different of the resistance. The conductance G is given by I with respect to V. Sorry, is the ratio between I and V, which is the inverse of the resistance. And working the algebra, we can rewrite this way. A detail, if we plug a generator on a transmission line, the sum of the currents using Kirchhoff's law, we always gonna obtain of with taking the generator as reference, all the values always gonna be negative. So first let's finish this modulation. So it's gonna be G times V plus the value of the capacitor times the rate of change of the potential on the capacitor with respect to time. And talking about the detail, when we see the current coming out the generator, the sum we always gonna be a negative, we always gonna obtain a negative value, seeing the generator as a reference, and is the same for this first section. So this is it. I hope you understand what I tried to teach you. And as I said, we have a voltage drop, and taking the generator as reference, we always going to be taking a negative values, applying a signal, plugging the second section of the transmission line, seeing the generator as reference, the values always gonna be negative, taking the Kirchhoff law, the sum of the current equals zero. Uh, well, uh, hope you understand now. And if I said something wrong, I'm gonna try to correct me on the next videos, and hope you follow along the the coming on videos. Thank you for watching. Bye bye.